Hello everyone, this is Amit Tiwari and today we are going to study about reactive and proactive routing protocols. In this video, we are going to discuss about classification of routing protocols, what is meant by proactive and reactive routing protocols, the comparison between both these protocols, performance metrics, and finally, we are going to discuss the result and performance comparison. So let's get started. What is meant by ad hoc network? Ad hoc is a Latin word which means for this purpose. It is a decentralized type of wireless network. It does not rely on a pre-existing infrastructure such as routers in wired networks or access points in wireless networks. The routing decisions are made by the node itself. Ad hoc network can be broadly classified into MANET and WANET. Classification of routing protocols. Ad hoc routing protocols is divided into proactive and reactive routing protocols. The proactive routing protocol is further classified into FSR, OLSR, DSDV, and FSLS, whereas the reactive routing protocol is further classified into TORA, ABR, DSR, and AODV. What is meant by proactive routing? This type of protocol maintains a routing table. Therefore, it is also known as table-driven routing protocol. The address of nodes are periodically updated in the routing tables of all nodes throughout the network. Nodes transmit hello message periodically to update routing table. Examples include DSDV, OLSR, FSR, and FSLS. Advantages of proactive routing. It has fast route discovery. Also, it has good reliability in packet delivery. Disadvantages of proactive routing. It needs large routing overhead. It requires periodic hello message to find routing changes. What is meant by reactive routing? This protocol does not have any predetermined routing table. Therefore, it is also called on-demand routing protocol. Here, node initiates a route discovery process throughout the network, only when it wants to send packets to its destination. Route discovery is done by using flooding of route request packets. Examples include AODV, ABR, DSR, and TORA. Advantages of reactive routing. It requires less routing overhead. It consumes less resources due to the absence of large routing tables. Disadvantages of reactive routing. High latency time in route finding. Excessive flooding can lead to network clogging. Now, we shall compare proactive and reactive routing protocols on the basis of latency of route discovery. In proactive protocols, there is little or no delay for route determination, since routes are maintained at all times, whereas in reactive protocols, there is significant delay in route determination. Employs flooding. Control traffic may be burst. On the basis of overhead of route discovery and maintenance. Proactive protocols consume bandwidth to keep routes up to date as they maintain routes which may never be used, whereas reactive protocols have lower overhead since routes are determined on demand. Which approach achieves a better trade-off depends entirely on the traffic and mobility patterns. Low traffic with high mobility for reactive and high traffic with low mobility for proactive. Let us now talk about proactive and reactive routing protocols comparison. The table shows the various routing protocols which are compared on the basis of scalability, reliability, load balancing, and also whether they are loop free or not. Performance metrics. The performance comparison of routing protocols are based on the following performance metrics. First, packet delivery ratio. Second, average end-to-end delay. Third, throughput. Packet delivery ratio. Packet delivery ratio is calculated by dividing the number of packets received by the destination through the number of packets originated by the application layer of the source. Average end-to-end delay. Average end-to-end delay is the average time in seconds it takes a data packet to reach the destination. This metric is calculated by subtracting the time at which the first packet was transmitted by source from the time at which the first data packet arrived to destination. Throughput. The throughput of the protocols can be defined as percentage of the packets received by the destination among the packets sent by the source. It is the amount of data per time unit that is delivered from one node to another via a communication link. Results and performance comparison. Performance of AODV, TORA, and DSDV protocols is evaluated under both CBR and TCP traffic pattern. Extensive simulation is done by using NS2. Let's observe the average end-to-end delay for CBR traffic pattern. The graph shows how the average end-to-end delay for the various routing protocols varies with the number of nodes. This graph shows how the average end-to-end delay for TCP traffic varies with the number of nodes for AODV, TORA, and DSDV routing protocols. Finally, let's see what can be concluded from the study. This study was conducted to evaluate the performance of reactive and proactive protocols of MANET based on both CBR and TCP traffic. These routing protocols were compared in terms of packet delivery ratio, average end-to-end delay, and throughput when subjected to change in number of nodes. Simulation results show that reactive protocols are better than proactive protocols in terms of packet delivery ratio and average end-to-end delay. This was all for this video. Thank you for watching. If you like this video, please press the like button. Also, don't forget to share it with others and subscribe to my YouTube channel. Thank you once again.